Welcome everybody to the second Exploring Group Project Administration video. We're going to talk about analyzing a project subgroup. Now I'm going to talk about this in relatively high detail, try to give you an approach that works. I'm going to give you some pointers to tools and ways to do this that hopefully will be helpful to you as a project administrator. They're not necessarily the only way to do it, and I'll talk about that during the presentation, but hopefully some folks will chime in at the end if I've forgotten a piece or if there's another way to do it that I didn't cover in enough detail or whatever. So all of this is specific really to family tree DNA projects, because that's kind of the easiest way to aggregate both the DNA information and the various members of your subgroup together. But it applies to projects in YFull. It applies to all of the testing that you might have done with other companies when you put all that together. Some of that is more manual than you have in the family tree DNA network, but the basic approach still applies. So don't think of it as only relevant to family tree DNA projects. The very first video that we did, which is on the YouTube channel, this one will go up next to it, but the very first video that we did was about how to split your project into subgroups and various ways of doing that. Again, there's not one way, but there are ways to do it that often result in your subgroups being, I'll say, major haplogroups. Obviously for surname projects, it would be closer to present day, not the older haplogroups, but generally you have a breakdown that is often very haplogroup focused. So we'll talk about how you do the analysis of the people who have tested who ended up in your project. So, and then some strategies for how you go on to do more analysis based on either new testers or upgrading or so on. Now, so like I said, you've got an entire project and we'll focus on one subgroup. You've already done the sorting to put them into. You've got subgroups of varying sizes. Some of them may be, depending on how you do your project, there may be one person in a subgroup. For me, I tend to only have subgroups when I have two or more people that seem to be connected. And so I create subgroups for them, but some people have even more stringent requirements and say, no, I'm only going to do a subgroup when I know that they're connected by genealogy, or when I have real, solid, or everybody's at big Y or whatever. There's lots of ways to do that, but we'll talk about taking one subgroup, however you've connected them, and trying to do some analysis on them. So, and hopefully you want to turn them into something. I picked a surname project here, but hopefully you want to turn them into something like this, where you've made some sense out of it. You've given the people back some information about how they're connected. If it's a haplogroup project, it's probably even easier, because then you're just telling people that they're related by SNPs that are probably closer to present day than they have, if they haven't done big Y, for instance. You might be telling some STR testers that they are related to people who have done SNP testing and encourage them to upgrade and so on. But, so there's lots of different projects and therefore lots of different ways that you're going to explain this to your members. Surname projects ends up being the easiest to use as an example for two reasons. One, because there's a lot of information that they have to pull together. So it's a useful way of talking about how you get your arms around that. And the second thing is because there's a lot of surname projects out there. It's probably the most common type of project, certainly not the only one though. So if your project is a little bit different and you have questions about how that works, or this doesn't really apply to how you've organized your project, feel free to reach out or ask questions online or in the chat, or even on Facebook or any of the other social media forums that you use in order to get that information, because there's probably other people who have faced the same problem you have. Okay. No matter what kind of project you have, I tend to oversimplify it and say that the cycle of analyzing one subgroup comes down to three things. First one is you're collecting all the data you have. This is kind of simplistic, but you'll see why I'm splitting it into this as I go through the presentation. You collect all the information you have available to you for that subgroup. You analyze it all and you put it all together. And then you come out with conclusions, and you decide then what else you need in order to draw either better conclusions or answer more questions or go further than you have. You get people to test, you get people to upgrade, you find new testers, you add to your knowledge, and then you collect all that up again and you go back through the cycle. And it's really a never-ending cycle of answering questions, posing yourself new ones, and going back to find more information. Now, you don't always So if I go into this in a little bit more detail, for Y-DNA projects, this usually means a combination of usually three things for sure: SNP data, STR data, and traditional genealogy data for surname projects, of course. And I'll talk about the STR data and whether you want to use it or not. That's always an open question. But then you could be combining autosomal DNA, you could be combining mitochondrial DNA analysis. There's lots of other sources of information. I'm going to somewhat oversimplify this and just talk about those three: the SNP, STR, and traditional genealogy. But think of this as adding any sources of data that you have available to you. I generally draw the analogy to traditional genealogy, where you're going to research, census records, maybe wills and other probate records. And whether or not you use land records is entirely up to you. But if it's available, you probably should look at them, so on. So second thing to remember is not all of your conclusions are going to be certain. And you need to remember that it's common to say DNA doesn't lie. The problem is it doesn't always give you the total picture or give you complete certainty about the things, about the conclusions that you're drawing from it. So bear that in mind. And I'll talk a little bit about what you can rely on and what you can't when you go through the analysis that you're doing. And then when you decide how to get more information, I can talk about how you decide whether you need to upgrade your current testers or whether you need to go out and find new ones, and some strategies for doing that too. So again, a lot to cover in the short time we have, and that's why some of what you'll find from me is general approach information, and the details we can work on, or you'll have to see how that translates to how your project works and how you want to apply those. What information is relevant? You probably have to look at it all. And this is the question that comes in of, should I use STRs or not? And people say, well, I say don't use them. Other people say use them. They're hard to use, they're whatever. Right? It's typically not an issue when you're talking SNPs, because that's easy to use. It's also very well organized. STRs are not very well organized. They're a little more statistical and they're harder to integrate into your project. My view on that is you don't want to leave any stone unturned. You don't want to not look at anything. There are plenty of projects where STRs don't help you at all. There are projects where they do as well. Unless you know that in advance, you're going to pick up a subgroup. You don't know whether the STRs are helpful or not. So you can look at them and see. If they're not helpful now, put them down, concentrate on the others, and look at other sources of information. Pick them up again once you've changed your subgroup enough that you want to know whether they're still no longer relevant or they are, and then go back through that cycle again. But remember, no two subgroups are the same. There's a lot of people who have one project and some subgroups in their project they can use STRs and some they can't. There's even projects where they didn't find any branching SNPs at all within the time frame of that particular subgroup, and other subgroups where SNPs are incredibly useful. So be aware that your experience with one subgroup is not going to translate to another. So adopt an overall approach and just apply that consistently to try and get as much information out of each of the subgroups as possible. Okay. When I go through here, I'm going to talk a lot in pictures. So I'm using this kind of as my picture of a subgroup. The black dots on the bottom are my individual testers that I've lumped into this subgroup together. And then, of course, I've got the ancestry timeline on the left-hand side. That can go all the way back into prehistory, if we're talking SNPs, of course, and you cover the modern, the Middle Ages, the ancient period, Iron Age, Bronze Age, and back into prehistory. And I'm going to talk about what information is relevant where. So the easiest one to talk about is SNP data, since that goes back, even to 240,000 plus years ago, back to the APR 2921 or whatever it is, SNP. And it's considered reliable, but always bear in mind with SNPs, it's not that the mutation is not reliable, but the branching that's been determined closer to present day can sometimes be dependent on how many testers you have. If you only have one or two testers on a particular branch, and especially if the SNP testing on the important SNPs in that tester have only been are sort of borderline as to whether or not they're positive or negative for those SNPs, that can be the information on a block tree, for instance, can be based on a very small amount of data that can change as more testers come in. So just be aware that although SNPs are very reliable, the conclusions that are drawn from them can change. And I do see every once in a while a particular project admin getting frustrated because what they had built in terms of a conclusion from their subgroup completely changes because, you know, family tree DNA gets a couple of new testers in and decides the block tree doesn't look like that. It's all going to be moved around, and all of a sudden the conclusions about what ancestors they thought these people were connected to does change. So just bear that in mind. If you have branches that only have a few testers on them, the information there might have to be put down with a question mark and just say that's our best information to date. STR data, if you use it, is really only reliable for analyzing a subgroup, I'll say within the last 1500 to 2000 years. Now, that also changes by subgroup. In some cases, you'll be able to go back further if you want to. In some cases, the STRs are so volatile that they're only good for the last 500 or 1000 years. It just depends on the performance of them within that subgroup. They're very good. I mean, they're actually good at predicting older haplogroups because the overall STR pattern is what they use for that. But the ones that change, which is how you decide whether they find branches within your subgroup, that can be too volatile, too noisy because they change too often and you can't see the branches in your subgroup. And I'll talk about that in a little bit more detail too. So traditional genealogy, of course, which we often call the time of records, is really only valid during the period where we have historical records. Now, some people like to go back to, you know, early medieval times or trace their ancestry back to people beyond what the records really prove, and that's fine. But when I look at traditional genealogy and what I can prove from it, I tend to be able to go back to the 1700s, maybe in Ireland. I can go back a little bit further in some other countries, maybe based on records, but generally I can't go back farther than that. There are people who connect to important lines that have been well documented, maybe nobility or somebody that has a pedigree going back farther. They can trace their ancestry back 800 years, sometimes even 1,000, with a fair amount of reliability. Those are, to my mind, those are flukes, but they happen. But I'm going to say sometime between now and let's say 1600 is about the time of what I call traditional genealogy. So that's the time when you're going to have records. You're going to be able to name your ancestors as opposed to just knowing that you have connected lines. And you might be able to associate named ancestors with STRs or SNP patterns, depending, I mean, with either SNPs or STR patterns, depending on what you can find. And then very close to present day, we have autosomal DNA, which, as we all know, you start to lose autosomal ancestors about 5 to 8 generations. And the pieces of shared segments get so small that it's harder to tell your exact connection to certain matches that share those little segments with you. So the reliability, it's not that it's not reliable, but the ability to figure out your connections to people starts to peter out. I'm going to say 5 to 8 generations, maybe a little further for some lines, but maybe a little closer as well. So that tends to be even more recent because you can cover the time of records, but perhaps not all the way back. Now, I'm going to leave autosomal DNA because it's a little more involved in talking about how you go from mapping your connections with autosomal DNA to finding what that means to your Y-DNA ancestry. There are some strategies for combining it as well, but I only have a short amount of time here, so I'm going to put that aside for a second and concentrate on the other three. So when we talk about this, what you want to look at obviously depends on what your project is and what your important timeframes are to look at it. If you're a paleoanthropologist, you're really only concerned with prehistory and ancient finds. You're probably not going to use STRs, traditional genealogy, and certainly not autosomal DNA at all. You might, but chances are you're going to be concerned with SNPs and the older period. If you're doing population migration studies, you're mapping, you know, the Pacific Islanders as they moved around, you're mapping the indigenous Americas migrations, you're doing some kind of studies on populations, cultures, how the bell beakers moved through Europe, you know, all those kinds of studies. You could do almost any period from prehistory up to the let's say into the Middle Ages, but you're probably going to be focusing on there. You might use STR data. I would say most of them concentrate on SNPs still. For haplogroup projects, certainly you'll be concentrating on SNPs. Now we start getting a little bit closer to present day. We start talking about the special interest projects, the surname projects, and genealogy, which really concerns itself has concerned itself in the past, at least, with the time of records and when we could name ancestors. And so that's where the overlap comes in between traditional genealogy, STR data, and SNP data. So what I'm talking about in terms of collecting the information and putting all together is kind of taking all this information, going to the time period that you're interested in and looking through and basically collapsing them all together and saying, what does it tell me? How do I learn new things about my traditional genealogy from STRs and SNPs, in this case, taking those as my additional information from DNA? How do I put all that together in order to come to a conclusion? All right, so I'm going to use the example of a surname project. And to do that, of course, I'm looking at the last, let's say, about 1,000 years. And the way I'm going to picture this, again, is the black boxes are eye testers. I've got a time scale, and I'm going to concentrate on the closer time scales now. But if I'm talking SNPs, of course, I'm going to expand that in a little bit. But so my traditional genealogy, I'm going to diagram like this. I've collected it all. I've asked all of my testers to give me what they know. And so simplified, I've got this structure where each of the testers has some knowledge going back in time. The black boxes are the connecting ancestors where they share an ancestor with someone else. And the purple boxes are the earliest known ancestors. That's essentially their brick walls on their patrilineal lines. The guys over here on the right all think that they connect to an even earlier ancestor around the 1400s that's named and that they know of, but they don't have those proven except for this one down here that has a proven genealogy back to them. But otherwise, they think they connect back to him, but they don't know for sure. That's what the dotted lines are for. So that's just a representation of a typical set of genealogy information that you're going to collect together. Where you get SNPs from, you're going to get SNPs from the block tree. You're going to get SNPs from the time tree. You're going to get SNPs from the Y full haplotree. You're going to get them from wherever you got them. And of course, your testers are going to give you what they're positive and they're negative for out of their results. By the way, this just got announced today, so I'll throw in an announcement on it. If you haven't seen Roberta's blog post, I will put in a link to that here. You can explore that. That is a time tree specifically for subgroups of a project. You enter the project name and it'll allow you to look at the subgroups, only the public information, but you can look at the subgroups of that project and get a time tree for them, which gives you essentially this picture for your subgroup. So, this is still the subgroup here at the bottom. You've got the SNP data that connects them all together, and that time tree allows you to do this by subgroups. So it's very powerful and it's brand new as of today. So check it out if you're a project administrator, especially. That could come in really handy. So I'll throw in that announcement for it here. But if I look just at the part of this that is going to be close to present day, I have maybe 4 SNPs, and the first one here in the center connects all of my subgroup, and then I have a few others that have been discovered. The way I drew this picture, the little T around each of the SNPs is the error range, so I don't know exactly when that SNP occurred within a range, but I know that it occurred about that time period. And then don't forget that sometimes, so I'm going to then have all of my testers who are organized like this. I'm just diagramming how they're going to come in the results, and on the block tree or the time tree, they're going to be spread out among those SNPs. So I have an overall SNP in this particular example that connects everybody in the subgroup that could be about 1,000 years old. And then more recently, I have 3 SNPs that connects a bunch of them. The one over on the far side here only is positive for 2 of them. So I already know, by the way, just drawing a conclusion, that they're connected by a more recent common ancestor. And I've got some bigger subgroups based on the other SNPs that connects them too. I might have gotten some results that look like this. I might only have 1 SNP in my whole subgroup that is positive for 2 Ben, and I don't have any other information from SNPs other than they share a SNP that's 1,000 years old. That's where you want to turn to maybe STRs or something else to find it, but you never want to leave any stone unturned. So obviously you're going to look at SNPs. My point is simply, not everybody gets detailed value out of SNPs. just as they don't get detailed value out of STR. So be aware that when this happens, you may have to explore further, and I'll talk about strategies for that. For STRs, if you're going to use them, you want to do what's called building a mutation history tree that shows here on the left-hand side. You're essentially going to go back to your earliest known ancestor for that subgroup, or the ancestor that connects that whole subgroup. You're going to build what's called a modal haplotype for that subgroup, and you're going to then expand down and decide if there's any major branches that are marked by STR patterns that have changed. The STRs here that I show just give you an example of where that sort of pattern is very visible. You can see these sometimes when you look at the data. They're not always apparent, and you want to use tools or some analysis techniques for finding those. So here in the example that I have, we've got, generally this particular subgroup has values for these three STRs that I've circled of 30 or 31, of 11, and of 12. And in this case, I've got three people that have very defined values that are in common of 32, 12, and 13. That is a branch that clearly branched off. It's possible for any STR to mutate in either up or down. It's not unusual for two people to share a value but not be connected. But once you start having three, even two sometimes can start to point to a branch, but three or more is a very definite indicator that these three people all share a closer common ancestor where those mutations happened, and they just happen to be descended from it. So that kind of pattern can come out through a mutation history tree. So I'll put these in the chat. So there are some places to go for learning more about mutation history trees. If you want to know more about that, the SAP tool can do it for you as an automated tool process, but you also want to look for the videos and the blog posts by Morris Gleason and John Cleary that explain this. They're a little old because this has been around for a long time, but they're still very applicable. So when we look at, are STRs reliable? I usually say SNPs are very reliable. This is my time scale, or my scale of reliability from wild guesses all the way over to proven certainties. SNPs are usually reliable. There is some variation in them because, as I said, the bottom of the tree can change. That doesn't mean they're not reliable. It just means the conclusions that you draw on them may sometimes change, but they're pretty reliable. STRs tend to be somewhere in the middle. And traditional genealogy research, let's not forget, is also very variable. The stories that your ancestors told about their ancestors may or may not be reliable. Obviously, we have primary records and secondary records, and all of the discussions about how much weight you put on certain things in genealogy has been around for a long time. So all of these sources of information can be reliable or not, depending. So the question of are STRs and SNPs reliable is a little bit like asking, is traditional genealogy reliable? The answer is it depends. It depends on your subgroup. It depends on who they connect to. It depends on what mutations have happened in their history. It depends on a lot of things. Again, going back to the point that you need to assess that for your subgroups. If I do rely on them though, and I put them together in a pattern, I might get something like this. Again, I could, like my SNP pattern of one SNP, I could have one pattern out of this or not. I'm just using a wider example for the example purposes and for how you put this together. But in this case, I have two of my groups here that have question marks because it's a pattern that suggests that those people are related, but it's not a reliable pattern. And then I have some more reliable patterns that have said, yes, they all connect. So that has given me these groupings. So now I have traditional genealogy information. I have SNP information. I have STR information. I've pulled them all individually. And I'm going to lump them all together, and don't bother trying to make sense out of this too much, but I just basically drop them all onto the same chart, and I'm trying to look through this. That's what the little dotted line is intended to show, and try to make sense of these. So when I look at this, what do I conclude? Well, I split these up into A through G just to reference them. If I look over at A, obviously the two people who are connected by that SNP are in fact connected to a closer common ancestor. And if the purple box above them was that ancestor's father, then I know for a fact, since the other descendant of his in A is not positive for that SNP, that SNP occurred in that common ancestor. So now I've identified what they call a SNP progenitor, which means the SNP occurred in that generation exactly. So that's nice. I found that out and I've been able to sort them together. They appear to be connected from STRs to group B by a common ancestor there. And then they all connect up to that SNP that's above A, B, and C. So now I'm starting to put together a pattern of connection that tells me how these people are related to each other. Over here on the right, I've got E, F, and G that are connected by what seems to be an STR pattern that suggests that there's a branch that connects all of them. And in fact, if you remember, they all had a history of connecting back to that earliest ancestor through those dotted lines. The problem I have with these guys is that E and F are positive for that SNP that I found, but G is not positive for that SNP. So now I'm looking at different generations, and what that means, and I'll show you, I'll flip over to, so sorry, let me just make the point first that I'm looking at concentric circles, right? So I'm looking at circles of relationships that are defined either by known genealogy, by STRs, or by SNPs, or in some combination. And I'm starting to make sense out of how these people must be related if all of that is true. In some cases, you're going to find that some of it is not the same. So you'll have a traditional genealogy story that says people are connected, and the information from DNA is going to tell you that's not possible. So now you have to deconflict that. Don't forget, it is possible that the testing has given you something that's not correct. Doesn't mean the DNA information is always right. You may have to double check that someone is actually positive or negative for a SNP. You may have to decide that that STR pattern really isn't reliable. Those are not always easy decisions to make. That's where you have to investigate the DNA. But of course, the traditional genealogy may be wrong as well. If I try to put all this together, I end up with a decision tree that I've put together that says how they're all related. The reason that the people at the top have question marks is because I don't know the names of those people. I don't know who they are yet. I only know that those are relationships that this whole group shares. Those they may be people that I can eventually name, or they may be so far back that I'll never know the names of those people. But E, F, and G, I was talking about, I've got a problem at the top there. They all thought they were related to this earliest known ancestor. And the SNPs and STRs suggest that E and F are connected to that SNP, and that G is connected earlier than that. He's not connected to that SNP. So is the earliest known ancestor the ancestor of E and G, and of E and F, excuse me, and G is actually connected to their father or their grandfather, or even further back? Or could the SNP represent that earliest ancestor's son, and G really is descended from that earliest ancestor, and the other two are descended from one son? All of those scenarios are still possible. I have to go through and eliminate them, probably through more traditional genealogy research, to find it. Okay, now if that all didn't make sense at all, get the recording and go back through it again, see if that made sense. All I'm really trying to do here is show you how you put all of the information together and you start to conclude how these people must be related if all of it is true, or you find cases where it's not true, and you start to say what scenarios are possible for explaining how this happened, what could be wrong, and what do I need to go investigate more. And these are the kinds of scenarios where you have some proven ancestry conclusions, like A over on the left, that's related to that SNP, and then related to an ancestor that they share with the third person in A, et cetera. And then some possibilities like E, F, and G's connection, where I'm pretty sure that I know how they're connected, or that they're connected in a close time frame, but I haven't identified exactly which ancestors are the parents, are the ancestors that E and F share, as opposed to where G comes in. So that's the kind of information that you now have to go on and find out, how do I test someone new? So now we get into the question of, how do I find people, how am I going to get new information into this group? So when you look at your existing subgroup, let's start there and talk about how to find some new testers later. So when do you consider upgrading? And by upgrading, I don't always mean spending money on a new test. It may just be looking at data that you haven't looked at before. a good example is if you've done a bunch of big Ys, but you haven't really looked at the additional STRs above the first 111, maybe you want to look at those and see if there's a branching pattern in there that makes sense for your group. Or maybe you do have to spend money if none of your people have taken a big Y test. You probably want to start exploring what the SNPs could tell you about the subgroup. But I tend to split it into two areas when you're considering upgrading. One is this box that I drew that takes all of the data that you've analyzed so far, and it says, look, not all of my people have spent the money to upgrade to the same level. I might have, 3 big Y testers and a bunch of Y37s. I might have a few Y12s, a few Y37s, a bunch of Y67s, and a few big Ys or 111s or whatever, right? I have all these different levels of testing. And that gives me this black area at the bottom, which is the missing data that I don't have yet in the subgroup. The first question you ask yourself is, what could that missing data tell me? Could it confirm some of the connections that I think are likely? Could it identify some new SNPs for me, or confirm some conclusions that I've made, or find additional data that would give me more information because I've only tested a few people, let's say to big Y. I think I have some STRs or some SNPs that are important, but I need to find more. So I'm going to take a bunch of Y37s and ask them to upgrade. So you're filling in this black area down below by asking people to upgrade, which gives you more information. And the second part that I look at above here is the new areas I haven't explored, either some levels that this group hasn't upgraded to yet. If none of them have taken big Y, then I want to start exploring what the SNPs could tell me. So I want people to start upgrading. But if I haven't started using some of the data that they've been able to give me, so the STRs are a good example, then I want to start using that. Even if your entire group has already upgraded to big Y, there are some things you can do to start getting more information about the group without asking people to test more. Sometimes you do, but sometimes you can, as I said, you can explore the additional STRs. You can send some of your members of the subgroup with permission, obviously, over to YFull to check out what YFull would say as a second opinion. They may stumble over a SNP that Family Tree DNA didn't call for some reason that looks important to your subgroup. You can ask them to do whole genome sequencing, a few of them, to see whether or not that identifies anything new. You can do a number of things. Some of this obviously will cost money. Some of it will involve using other companies. All of those are questions you're going to ask yourself. But if you're exploring ways of finding more information, don't think that big Ys are the only, are where you stop with that, because there's always ways to look at them more. There's also a few other things you can do, like check out all the private variants that have been tested and see if they've truly been covered by every test, because if they haven't, then they might be important if they might possibly be positive in someone else, and so on. But all of those tend to be long shots. They're not necessarily a proven way of getting more information, but they're things that you probably should check. My point, though, is you want to upgrade or check out that kind of data when really all you need is getting new DNA information to add to your analysis, because you're not going to learn anything new about traditional genealogy by testing your existing members. They've hopefully already provided you everything they know. Now, a separate track is you might be asking them to do more genealogy research, or they might discover something on their own, and you'll learn something new that way. That's fine too. But if you're looking at upgrading DNA information from your existing team, the odds are you're not going to learn any new genealogy information from that. You're just going to add some new DNA information. On the other side, you're going to look for new testers when you need to add both DNA information and a specific genealogy pattern that has to hold for you to learn something new. For instance, if you want to prove that a SNP occurred in a specific ancestor, you have to find a descendant of the father of that ancestor to test to prove that they were negative for the SNP. In that case, you are adding genealogy information because you're finding someone connected to that father. or you're going to, there's some new there's some historical figure that you haven't fit into this subgroup, but everybody thinks they're related to them. You haven't found a descendant of them yet. Again, you're finding someone new to add both the genealogy information back to that historical figure, as well as their test results to tell you whether or not they're part of that subgroup, and so on. Or you're breaking up SNP blocks. Again, it's the combination of the fact that that person that you're adding is in that genealogy plus the DNA data that's going to help you break it up. So when you add new testers, it's going to be because you want to really find both additional additional DNA data and add a new genealogy situation to your analysis. So that's the basic difference between those. At some level, it almost doesn't matter if you're exploring. If you've said, okay, I've concluded as much as I can now, and I just want to learn more, and I don't have a specific question. At that point, finding anyone you can who can add value to your analysis is fine. And that gets into some of the recommendations for how to add new testers. Where do you find these people from? Well, of course, the common strategy is you just wait. And sooner or later, someone will test who belongs in that subgroup. Unfortunately, that can take years. And when you don't have any other sources of knowledge of that subgroup or ways to find people, that is often how people learn something new. They tend to stop in this cycle and wait for someone new to join the team. And sometimes that takes 3-4 years. And someone is all excited because a subgroup that never moved for 3 years suddenly moves because someone new has dropped into the project. You can, however, look for people and hopefully have a better chance of finding them sooner. You can look at their matches for anybody who hasn't joined the project. Obviously, if it's a surname project, you'd be looking for people of the surname, but don't discount NPEs or people who have different surnames. They can be very valuable to your analysis because they can tell you both positive DNA information that can help you and negative. If they're negative for something, that can tell you as much as whether or not they're positive. So don't discount NPEs. If they branch off your group in the right timeframes, they can still tell you a lot of useful information about that subgroup. You can also go through the autosomal route and look at if your subgroup is tested autosomal, of course, you can look at their matches and decide if there's anybody in their matches who's likely to either be a male or have a male connection, who would be connected to your subgroup in the patrilineal line so that you could learn something from them. People have discovered connections that haven't even taken a Y-DNA test by exploring the autosomal connections. Obviously, those are probably people that are closely connected to your subgroup, but that's something which you can still explore. You can go back and trace the descendants of your subgroup and find other descendants that are connected to them and ask them to test that way. Go through Ancestry.com's trees, go through surname associations, go through anybody that's done research or that has a connection to someone who might have done research to be able to find those people. You can go through haplogroup projects and look for testers who might be just outside the match limits, so they don't show up as matches to your subgroup, but yet they might be closely connected enough. You can look, you can walk through a region of the world and hand out tests. I know many project admins who have done that. It's not always a high chance of success, but it's been successful. I've had success one time when I did that, by the way, of finding someone who agreed to test and who was connected to my subgroup. I've done it a few other times, and a few people have taken tests and ended up not being. All of it tells me information. Not all of it is exactly what I was hoping for, but you always get new information that way too. Now, I will say you can test known relatives. So people sometimes say, hey, should I ask my brother, my cousin, someone to test? My usual answer to that is sure, if you know that that will help for you. Usually when you test someone that you know how they're connected to you or to anybody in your subgroup, you're not going to learn anything new genealogically. You already know how that person is connected. You don't need to, you may need to prove it, that's a different question, but assuming that they are descended in the same line as them from a Y-DNA perspective, you're not going to find out new information for the genealogy since you already know that information. What you might do though is you might build a better understanding of the SNPs and how they're connected, or you might be able to confirm the order that certain SNPs are in. You might even be able to break up a block if they're connected to you in a time frame where you have an equivalent block of several SNPs and so on. So I usually say you're going to learn something new genetically from that, but probably nothing genealogically. You're not going to break through earlier brick walls. You're not going to learn the names of your older ancestors. You're not going to find a connection outside of the connection that you and that close relative already share. So it may be perfectly valid to do from a genetic data standpoint. It probably won't help you genealogically. That's my usual answer to that. Doesn't say you shouldn't do it. There's plenty of questions you might have. There are people who build very deliberate and complicated SNP trees for their own descendants to pass on, that says, here are the SNPs that occurred in me, my uncles, my father, and that's fine. So that gives your descendants more information when they do this analysis themselves. Nothing wrong with that. So anyway, your end goal obviously is to explain it to your groups. And this is where I'm not going to go into a lot of detail on this, but this is where you can put together the picture any way that makes sense to you. I tend to do this, and that's why some of these examples reflected this kind of picture. Again, going back to the earlier one, this is another one of my subgroups where I put together a picture where I have the colored groups that are SNP descendants, and then I put all of their lines. I privatize the bottom, but I put all their lines in, and I put the ancestor connections that we know of, even if we don't know their names and so on. How you choose to do that for communication purposes is entirely up to you. Again, going back to the cycle, again, this is at this level, it's a little bit, obviously, it's a bit obvious, all right? You're gonna collect information, you're gonna combine it all to draw conclusions, you're gonna see what you need to find to draw more conclusions, you're going to collect that information and go around again. The devil's in the details. The important part is how you do it, what you look at, what tools you use, what reports you're looking at, how you rely on the information to put it all together, and what conclusions you're going to draw. So that's where when you have questions, when you don't know how something works, when you don't know how other people have done something, reach out and find out that information. But hopefully, if you didn't know how to organize a subgroup or put it into a structure that helps you make sense of this, hopefully the start of this at least gives you ways to organize that information and go a level down. Then when you're stuck with, how do I look at STRs, or I can't get all the traditional genealogy information, then there's individual areas that people can help you with. What I didn't want to do with this, or what I was trying to do with this video, is be able to help the people that say, I don't know where to start. I have no idea. I've got this subgroup. I don't even know what place to start. And that tends to be the starting project admins who have most of those questions. And that's why, for the experienced folks on the call, I'd like to get your reactions next as to, is this the same approach you basically use, just translated into my language, or do you do something so completely different that it's worth calling out and giving people that example as well? So with that, I'm going to pause and ask people to open up their mics and ask questions. If people jump in, just wait for someone else to talk and we'll get to your question. Again, I did go a little bit long, but hopefully that was useful for people. I'm going to keep the recording going until the open mic period is finished, and then I'll stop it.
Dave, you did not have any questions asked in the chat.
Okay, thank you for that. Then what is people, okay, for those of you who've done this a lot, any other comments to make? What did I get wrong? What do you do this different?
Giancarlo Marquez says that was useful. Thank you.
You're welcome.
Hello, Dave. Dennis O'Brien.
Hey, Dennis.
Your logic is exactly the logic I've used with our grouping. Almost identical.
All right. Well, thank you for that. So, James, you've done this for a long time.
Yeah, I admire the way you presented this. It clarifies a lot of things that one stumbles upon unconsciously, as it were. Nothing surprising I've learned, but what does occur to me is that there is another dimension to this, the amount of time you have and the size of your project. If you've got a very small project and a lot of time, you can go into this in a huge amount of detail. If you've got a big project or a big subgroup and you haven't got that much time, the options that you're discussing are almost academic. I'm somewhere in the middle. I struggle to keep up with the new testing coming in, and I've got a lot of other interests, including genealogical interests, but I haven't got the time to do all the thorough searching that you suggest. It's just beyond me. I think this dimension of time and resource and size of project is one that is very relevant to different people.
Yeah, no, that's a very good point, James. The fact that it's easy enough to say how people should do it, but available time from volunteers is always a limiting factor. That's I will say that's one thing that some groups have successfully overcome with either joint admins or co-admins and a small team doing it, because they can parcel out the work. But that always doesn't work for everybody. You know, not everybody has an army of co-admins waiting to step in. So
Exactly.
yeah, you're absolutely right. That certainly is a limitation, and I'm certainly guilty myself of seeing new information come in because my testers are upgrading themselves, and then not having time for weeks to go back and look at it and see what
Yeah.
it means.
Yeah.
So
Yeah. Yeah.
no, that's a very good point. Thanks for throwing it out.
I would say that the new group time tree might be a tool that new admins could rely on to do their subgrouping. It just seems like a nice, simple way to split things up. Of course, it depends a lot on who's done big Y testing and does not take into account the STR only testers.
Right. Yeah, no, you're absolutely right. That's something that that I'm going to play with a lot more. But it does look like a game changer for project admins in terms of being able to put their and actually also even for explaining things to our members, right? Because it's a nice way of capturing the picture and sending it out to them. So for a lot of reasons, I'm excited about that tool. Yeah.
Got a couple of questions. Sorry, Dave, got a couple of questions coming up
Yep.
in the talk.
Yep.
From Larry Doyle, he says, is there a way to identify Big Y 500 or 700 in the spreadsheet that you download, downloading from the project? I can see Y11 by looking at the number of STRs for individuals, but wondering if there's another indicator.
There isn't a way to do it in the STR data that you download, right? Because for admins, you've got the option to download the whole project, and that only gives you the STRs and the estimated haplogroups. I don't think there's any way to tell it. I'm pretty sure there's no way to tell it there. Whether or not there's any other reports that you can download, I think there are, but I'm struggling to remember which one it is. And so it's a good question, Larry. I'm going to say I don't know of a way off the top of my head, but some of the other reports that you have might be able to tell you that. The problem is then you've got it and it's separated from the other things you're downloading, like the STRs, and you have to put it all together still. So it's not necessarily the easiest in the world, but I don't know how you do that. I tend to download the CSV files and analyze them that way, but even that doesn't tell me exactly which ones have taken 500 versus 700.
It is identified in the matches information.
It is.
If you're
You're
a group
right.
administrator, you can go into the match information for a member of your project and look at the matches and see who has tested at that higher level. And that's what I do. I take that and input it into the CSV file.
No, you're right.
We've got another comment here from Chris Hingerty. Thank you for a fabulous session. As a beginning admin, it was very helpful.
Thank you.
From Jay Cross, he'd like to know if I can get as many people as I can to do Big Y, is it a possibility to get some sort of group discount?
It's a good question. It's something, unfortunately, well, assuming you're doing Big Ys, it's something only Family Tree DNA can answer. I see Wesley shaking his head no.
Yeah,
I don't know if they do.
I would suggest making sure that you put your information in to get those other people tested at a time when somebody's running, when FTDNA or whoever is running a special. Yeah,
that's fair.
The holidays are great times to do that.
I will say,
the Roots Tech conference, there will probably be a sale too, March 2nd to 4th.
Good
Yes,
point.
there will be.
Good point. I will say that I have used YSeek in some cases to test individual SNPs for people that I just wanted to find out pretty cheaply whether or not they were positive or negative for a SNP, right? So that cost me $19 basically to find out, but it's information that's not connected to the rest of my project, so I have to integrate it manually. And it gives me no other useful information about that person than that one data point. So I can't I can't then, because you'll always have a question beyond that. Okay, all right, good. Now that I know that they're negative or positive for that, now I want to know this about them. And then you have to go test again. And you end up on this cycle of, I'll just spend a little bit more to test. And by the time you're done with that, you probably should have gone to take a big Y or something to begin with. So I will caution people not to get on that path. It's a little addictive because I can, throw $20 out here and there to learn all sorts of things. And I'll end up spending hundreds of dollars. I've caught myself, thinking about that. Thank goodness I haven't done it myself. But yes, I've done that too. So anyway.
You have another one from Larry Doyle, and this might
Mhm.
actually introduce you into actually doing a different presentation. Once you have broken your project into haplogroups or other subgroups, how do you use SAP to further analyze? And
Right.
how do I look at STRs beyond 111 that you mentioned?
Okay. The easiest, so those are two separate questions. So first of all, SAP is, unfortunately, I don't have time to go into today, but you're right, Mags, that would be a great presentation. There is, if you go to the SAP website that I linked above and you go to the FAQ, the first site gives you links to 3 or 4 videos that you can try out. They're not necessarily the best because you'll have to hear me babbling on again, but you can at least find out the basics of how to use it. Happy to help if you have more questions. You can find me on social media or over email. The question of STRs beyond 111. So I'll tell you the way I do it. I go to the sites, I go to each one of my members of a subgroup. I go to their STR page and I click the CSV button that downloads all their STRs. That includes the additional STRs beyond the first 111. I take all those CSV files, I go to the SAP website and I use the tool called CSV analysis. I put all of them into that and it comes out with one file that has all of them in it. I can then either import that into a spreadsheet if I want to, or if you run that through SAP, that'll handle all of the STRs, the first 111 plus the extras. It'll do an analysis on those and tell you if there's any branching patterns in there. So if you're a SAP user, that's one way to get SAP to do the work for you. If you're not, and you want to try that route, you can either, again, contact me or the videos also talk about it. So, it's the only automation. I'm sorry for plugging my own tool here, but it's the only automation that I'm aware of that allows you to put that together. Unfortunately, Family Tree DNA doesn't give you that option yet.
No.
Hopefully they will
And
someday.
Dave, if you have YDNA above 111 and you've uploaded to mitoydna.org,
Thank you for that.
mitoydna.org also gives you all of those extra STRs all the way up to 838.
Thank you for throwing that out, Megs. I don't remember to comment on mitoydna enough, and I should, because that's a
Thank
great
you.
site too. So thank you. The other question is, as project administrators, would you rather see a patrilineal line as a tree, not including the maternal lines? The graphic stuff is everybody's preference, right? There's lots of ways to do it. So would you rather see the patrilineal line as a tree? I would as a YDNA project administrator. The people in my projects might like to see it in context of their own genealogy. So it's a little more complicated than just saying what I like to see, right? For me, it's easy enough to make out those connections and that difference. For my teams, I want to get that feedback, and the people who have tested and want me to help them analyze it, I need to help get, I've got to get them to help me. Now, I will say I've spent long enough with my project members that most of them have been worn down and accept what I send them now, but I'm very happy to get information from them as to how they like to see it, and I try to adapt that into my analysis. So I can't answer the question for everybody. I like to see it that way, yes, but.
In our project, we strip out everything except the patrilineal line because we really want to focus on connecting these families.
Yeah, no, that's fair. I'm going to stop recording because we're going into other subjects, but does anybody have a comment on the subgroup analysis before I do? Okay, then I'll